I'm really stressed for my midterm, so I thought playing would be a good way to blow some steam.
Okay, well I understand you're stressed, so that's why I ordered a personal tutor for you.
I don't need a tutor.
Hi, I'm the personal tutor for PLB 112.
Oh, the mom sent you?
Yeah, I see you're playing against the piranha plant.
Yeah, I'm trying to beat the piranha plant.
Did you know that the piranha plant got its inspiration from the Venus flytrap? It actually exists in real life.
Really? No way.
Yeah, let me show you. Come with me to the Botanical Conservatory.
Here in Davis?
Yeah.
Alright, I'll go with you. Oh my god. Catch him with his teeth, crunch him up.
Yeah, but two of the hairs have to be triggered on each leaf.
Oh wow, that really is amazing.
Want to learn about the mechanism now?
Of course I do.
Carnivorous plants, such as the pitcher, sundew, and Venus flytrap, evolved in swamps.
Oh, like the swamp where Shrek lives in?
Yeah, swamps contain nutrient-deficient soils that are lacking in nitrogen and phosphorus. They are found in swamps where excess water washes away these nutrients from the soil, so carnivorous plants had to obtain nutrients other ways.
So when I was playing the Smash Brothers, the piranha plant came out of a pipe. Does that mean that the pipe is lacking in soil nutrients and that in order to survive in the Mushroom Kingdom, it needs to consume other critters like the Goomba?
That's right, Luigi. Similarly, Venus flytraps consume insects such as flies, bees, and mosquitoes, but they're not large enough to consume humans, so your video game is unrealistic.
Ha! That's why I always beat the piranha plant. My characters are always the biggest ones.
Sundew plants, which are the simplest of their carnivorous plants, have a sticky mucus that catches insects which come in contact with it. Next, we have pitcher plants, which contain vertical tubes filled with digestive enzymes that digest insects that fall into it. Lastly, we have the Venus flytrap, which is the most sophisticated of the carnivorous plants. It has a snapping mechanism that allows it to catch insects that come in contact with it. The Venus flytrap catches bigger insects than the sundew plant. Here the beetle crawls onto the sundew plant but destroys it. Next, the beetle crawls onto the Venus flytrap but gets eaten by it. So the Venus flytrap obtains more nutrients than the sundew plant. Here is the general structure of the Venus flytrap. It has 4 to 7 leaflets or snapping traps that can capture prey. Each trap is held by a stem and opens its leaflets so that the prey can crawl on its lobes. Each lobe has 3 hairs which serve as sensors, telling the Venus flytrap when to close, and the spines serve as prison bars, preventing the prey from escaping.
So how does the Venus flytrap crunch up the flies?
First, it depends on what it senses. If you have a water droplet that stimulates one of the hairs, this causes an action potential in the cells, but it doesn't reach threshold value, so it remains in the open convex shape. The convex shape has more water on the inner cells than the outer cells, keeping the Venus flytrap open. In another scenario, we have a gnat that crawls onto this trap in order to scavenge for some nectar. It touches 2 of the hairs within 30 seconds, which triggers an action potential that passes the threshold value. This causes water to move from the inner cells to the outer cells. And this change in trigger pressure causes water to move, which causes the trap to change into the concave shape, closing the trap.
So the gnat will die in the Venus flytrap prison?
Actually, the Venus flytrap isn't closed fully, which allows small insects like the gnat to escape, This maximizes energy capture for the Venus flytrap so that it can obtain more energy from bigger meals.
So the Venus flytrap has a big mouth? I'm getting hungry.
Are you hungry for beetles? One of the Venus flytrap's favorite foods are beetles because they are the bigger prey. In this scenario, the beetle crawls on the lobes and triggers 2 of the hairs within 30 seconds. Then the trap closes partially, but the beetle is too large and can't escape through the small openings between the spines. So it runs back and forth, triggering more hairs, causing the trap to close fully. The third time a hair is triggered, this causes the release of the hormone jasmonate. The buildup of this hormone causes the cells to release digestive enzymes after it closes fully.
So the beetle suffocates and dies?
Yes, the beetle dies mostly due to the lack of oxygen. The Venus flytrap releases salt, which allows it to absorb water from the beetle. The digestive enzymes break down the fly and allow it to obtain nutrients such as nitrogen and phosphorus.
Delicious. Does it open up again right after it's done eating?
Well, it actually takes 5 to 7 days before it opens up again, and the trap can only catch prey 2 or 3 times and then falls off. So those are the basic mechanisms for the Venus flytrap big nasty. Do you feel more comfortable answering the question of the day tomorrow?
Yes, I do.
Good luck.
Thank you.
So, question of the day then is, any takers on that?
Hey everybody, so my name is Luigi, and over the weekend I was playing some Smash Brothers, and I was a little curious as to how the piranha plant was thought of and invented. There are certain differences between the piranha plant and the Venus flytrap. One of them is that the piranha plant only has 1 head, while the Venus flytrap has 4 to 7 traps or heads. There are also similarities between both. They both grow in nutrient-poor soils. For example, the piranha plant grows in pipes that have no soils, and the Venus flytrap grows in swamps that also have no soils. They are both also carnivorous plants. The piranha plant munches on some Goombas, while the Venus flytrap chooses insects or beetles as its preferential meal. There are also mechanisms for the Venus flytrap. There is partial closure of its 2 leaves through triggering of 2 hairs. This causes action potentials that causes movement of water from inner cells to outer cells. This partial closure allows smaller insects to escape and helps the plant preserve resources. There's also a mechanism whereby 5 hairs are triggered, and this causes complete closure and prevents larger prey like beetles from escaping and allows the plant to digest them and use them for nutrients. In conclusion, the piranha plant was inspired by the Venus flytrap based on its unique way that it can capture and digest prey. This is in contrast to what most of us think of as ordinary everyday plants.
Okay, good job, man.